Good evening. My name is Wahid Lutfi. Welcome to my Web University free educational videos. Tonight, I'm going to show you how to use Jupyter Notebook or Jupyterlab. Last night, I actually posted this Happy New Year 2023 from my Web University website saying Happy New Year to everyone. And then the website that I use, https://colab.research.google.com. This is basically the collaboration.research.google.com secure page for Jupyter Notebook. And the command that I used mostly was the Figlet packages that I installed it because I had root access with this with this bang command, that you can run any Linux command or Python commands that are operating system related, like pip install or some other commands that are OS related. So this was a demo on this video that you could see here, but you might be wondering, saying that, Wahid, yeah, I like this command that you did, like uname-a showed me and the operating system. And then at the same time, I'm going to just kind of like remind you what I did in order to just come up with a question that you might be asking yourself, saying that, yeah, this is good. I run this command on a Linux VM that is hosted by collab.research.google.com, but I like to run similar commands and then on my Windows machine or my Mac machine. So on local machine, KTC etc OS-release. As you can see, this one is running Ubuntu version 18.04. But on your Mac command prompt, if you just open a command prompt, you can see that it is running Microsoft Windows version 10. So this is a Mac versus the VM is a Linux. And you might be saying that I wish I could type in something like shebang and then the Windows commands and get the output there. And the good news is that, yes, you can do that. And how you do that one is by installing Jupyterlab or Jupyterlab notebook and so on. Let me just show you how to do that one. So assuming that we no longer need this one because I don't need to show that, I'm going to just go to command line here. So on the command line, if you just are doing a pip list and then do a find/i and then look for Jupyter. As you can see on my machine, I already installed it. So if Jupyter is installed, all you have to do is just say Jupyter and then --help, and you will get the list of commands that you can do. For example, Jupyter run, Jupyterlab, here, Jupyter Notebook, all of those ones we can start. But in order to just show you more, I want to just show you that if you don't have Jupyter, when you do this find a string and it doesn't return anything, it is not installed, these lists will not show for you. If it doesn't show, what you need to do is say pip install and then Jupyter and then lab. So Jupyterlab is the one that you want to install, this one. Jupyterlab is installed. If you just do this one again, since it's already installed, it's going to just say, and this is already installed, so the requirement is met. It's just going to pass on all of those ones. Python and PIP is really smart. It says, these packages are already installed. I'm not going to touch anything. And as you can see, it says requirement already satisfied, requirements already satisfied on all of those ones. That means I have it, and that's why the command find the string, and that was just listing it. And if I'm just looking at only the lab, I can do that one, and then it will show only this one. but notice that there's other one servers and everything else. So the one that I'm interested to start is Jupyter Space Lab. And let me show you the syntax on that one. And this one is taking a little bit long, but it did show up Jupyterlab with 3 of these instances. So clearing the screen again, if you type in Jupyter, and then -- help, and then you can see the arguments that are passed in. It says available subcommands. Here it was saying subcommands, the command name. So available subcommand, the one that I'm interested in is either notebook or lab. So let me just clear the screen and start the lab. And I say Jupyter, like this. Notice the difference between the planet Jupyter with Y here is instead of I is Y. So Jupyter and then lab. This is going to start browser connections on port 8888, 48. As you can see here, localhost, which is the same as 127.0.0.1. That's the loopback interface, and it's booting the Jupyterlab. As you can see here, Jupyterlab is coming, and this is a very nice interface. I already changed the setting a little bit. By default, the setting is white color and backgrounds, and then you can just go under the setting here and say a setting, and then just say Jupyter light background, and it will just do light background if you like a light background. But because of these interfaces that I really look at it, is darker is good for my eyes. So I just use it setting. It's your choice. If you prefer to use white, and then it's just use white. But I'm just gonna use the dark color scheme, and that is there. So I already wrote a few NumPy stuff, but that's a different examples that I'm gonna show you on another instance. And when I'm teaching you NumPy, at this time, just make sure that you go to my Web University free education videos, subscribe to our channel. So when I just send the information, a new video that I'm loading, you could get notified, and you are welcome to watch them. So at this time, let me just show you a few of these options that is on the Jupyter. So if you just click on another tab here, you can see this interface comes in. It gives you options that what is available for you. So like here is Python, the kernel itself, which is going to give you an interface here. So you can start writing a program. So I was telling you that, yeah, you can just do the same thing that over there, except instead of uname, you type in the operating system related to Windows. So like if I type in hostname on both of them, it works the same way. But here I could say like dir command, just to say run the dir command. You can see the output is shown here. And it's nice that you can get commands after commands. And if you just want to just run another command like this, let's say Python -- version. So you can see the Python -- version and run it. It shows there. And then if you do pip list, and then do the same thing, that find a string that we did here, /i, and then we can look for NumPy, for example, to see if NumPy is installed. By default, NumPy is not installed, but you have to do a pip install, which I have already done it, and that's why NumPy is available for me. You can see here. So once you run something like NumPy is there, you say, well, let me just look at NumPy here from this interface. I could say import NumPy as NP. And then once you do that one, and then you can run code here, say A is equal NP dot. Let's just create an array of some variables, some less comprehension, I'm going to do this one. You could say x for x. Let's do x to the power of 2. X to the power of 2. And then we could just say for x in range of, let's say 20. And then f x mod 2 is not equal 0. So we start with one negative, odd numbers, not equal 0. And then just get me the list. So I'm going to say print A. And just to show you some capability of Colab, not Colab in this case, Jupyterlab, you can see that I get the list of these numbers with this even numbers. So somehow, because I'm multiplying them, I get different numbers. And then I could say, if this one to the power of 2, any numbers to the power of 2, you get back even numbers. So if I just say to the power of 3, then we get a different set. You can see it as odd numbers. It doesn't matter if you get even numbers or odd, but I want to just show you a few things here. We could just say print a dot number of dimension. What is the dimension of that one? You could see it's one-dimensional array. And then we could say print a dot shape. What is the shape of it? Obviously, and we could get the shape, which is 10 digits here. If I change this one to a 10, then we can get half of that one, which is 5. And then, but you see that this was, when you run this one, the last code is going to run. In order for me to get the output of this one, I have to select this one. Then I go run, select it, this one, now I get 5. Similarly, if I now just change this one, the dimension is still this, but the value here that are coming is different. So I have to rerun that cell. And if I point to this cell now and say run that cell, then you can see that value changed. And then from here, I could do a number of things. So for example, if I just want to add only these 2 cells, or just multiply the whole thing or add the whole thing, let's just do a few of these things and then we stop this video. But I will do NumPy in more details on another video. But let's just say print sum of A. That's as simple as that. It just add up all the numbers with that. So I'm going to just, instead of sum, I'm going to say product of it. You can see that it does computation on that one. And then you just have to say prod of A. Oh, NumPy dot prod of A. I cannot, sum was already a function. So you could have done sum here similarly, and you would have been able to do this one. It would sum up. Now you're doing as a NumPy, you could say prod. The NumPy is really, really fast because it's a homogeneous data structure. The data types are the same, and then the it's also contiguous memory, and then also there's no overhead for the size or the type. The type is all the same. So it is much faster. It is written in C, and so it is like running in C, basically your code. And the NumPy is very, very efficient. It almost replaces the MATLAB library. But you can do MATLAB, you can do NumPy, Matplotlib, and all those things. Panda, I'll show you a lot of those stuff as we get time. So right here, we are looking at this one. And then if I just want to say, I want to get the addition of only product of the first 2 numbers, which is, where did we print the, somewhere we printed now. Let me print it right here. We say print A, and then we just run the cell again. So I want to say 3 times 9, and I should get 27. So At this time, we're going to say cell 0, 0 to 2, and then just add those two. So you could just define the cell that you want to do, and then say run selected, and now you get 27. If you want to get so times 15, obviously it's 0 to 3, cell 3, and then that would just run sub 2 also. The index is always the start to 0, so this is index sub 0, sub 1, sub 2, and then 3 is not inclusive. So that's why you get the multiplication of those ones. Similarly, if you just change this one to adding, you could just, sum, you will get the sum of those three numbers. And then if you just want to decide to say, let me get the standard deviation between these two, you can run that one and you get the standard deviation. If you get variance of it, you could get variance. And then there's a lot of options. NumPy is full of this kind of documentation. So if you do help on NP itself, look at how much information is there. So let me just say print help on this one. You can see that if I run it, it is a lot of information. This is going to print it out here. And when it is slow a little bit, it is taking time to run the output because it's a lot. Notice this thing is really huge, and you can see the NumPy, it's like some hundreds of documentation that you can get from the doc string or help string here. But then you can also limit it yourself, say, like, for example, number of dimension. If you just want a specific, you could just get that one, and notice that is fast. And with this, you can also try something like question mark in P dot, let's say, shape. And then just run that one to see on Jupyter Notebook and other ones, you should get that information. You can see, you can get the help, quick help on this one. So anything like, for example, A is created, then since we say A, we are getting the same thing for A for help in P.A, or just say, let's say type of that one. You could get the type of in P.A, print it, run here. So you can see that in P, and this one is, since it's A is already defined to be that type, you can say NumPy dot this. You can also get print A dot dimension type, data type, to see like what is the data type here, and you can get that information. So there's a lot of details. I'm not going to show every one of them, because just by going to door of in NumPy, you can see that how much functionality and methods that are available here. You can see, look, there's a lot. So I'm going to cover it in a number of videos, not even 1 or 2 or 3. It is a lot more, and that we have to be working on this one. It's almost like teaching you MATLAB at the same time, plot lab, pandas, and everything. There's a lot of code in there that we can go through. Okay, so, and just to let you know that you can run these commands, like I did the directory command here. I can say 3C colon slash user slash Wahid slash programs. So let's say I want to see all my programs directory at 3 of it. I can just run this cell, and then just say run this cell, selected cell, and then it gives you the output there. So then these other ones, if I'm done with them, I can close them by deleting them. I don't need them, I just close them, and then I only run the one that I need. For example, let's say here under programs, I could see Python. Then I could just say run this one and show me the Pythons. And then if I just say C colon, let's say directory c:/user/wahid/programs, and then I say /subdirectories. Just list all the subdirectories, and it's going to just run, and you can see that the files are there. So you have options of running operating system commands as well as Python, as well as everything else. If you just say, well, let me just get a list of the PIP that are installed, PIP list, and then just run this cell. There, this one is going to just generate the list, and it did. So at the same time, when you just close these ones, if you say discard it, I don't need it, or save it, whatever, I can always look at this one. This is the console. So on here, if you just click on the console here, terminal, you get a terminal console here. So you're on a PowerShell command. You're in the PowerShell command, you could say git dash process. You can just run the PowerShell commands as well. Git dash help, or anything that you want to start the process, stop process, all the things that you have, aliases. You can just get a list of aliases and so on. All these commands that are there, you can just run them. But at the same time, clearing the screen here, and you do directory, and then this file that are there, like NumPy, for example. Notice that if you do a type NumPy _ demo1.ipynb, this file, if you run it with a /, this is gonna open either Jupyter Notebook, either Visual Studio Code or PyCharm. If you have Visual Studio Code, it will open it. But if you run it with the type command, whatever the JSON file information that is stored on this one, it will just show you all the arrays and data structures of JSON. So that's one thing. And the next thing, if you want to run this program and this you have to either go to Visual Studio Code, or you run it inside your Colab. At the same time, if you have a Python program like prog1.py, type prog1.py, now that's the code. I can say /prog, or I could say Python prog1.py. I could run it there too. I also can get into, from here, I can also get to Python. Let me just make this screen a little bit bigger and fonts. Control, I should have done it a little bit earlier, but it's okay. Control minus, shift minus. It's too small and big. So let me resize it a little bit, control minus. Yeah, so this is good enough. If I just want to say, on this one, I could say directory, and then as you can see that I say Python 3, and then say prog1.py. That will run the code. At the same time, I can get it to Python 3, and then you can see I'm on inside Python. I can also say import NumPy as NP, and then just once it's loaded, I can say dir of NP, and then do a lot of things with it. So import OS, and then say os.system, let's say clear screen. I could have done that one, and then at the same time, let me show you a couple of things with this as well, since I'm here. Right here, let's say with the NumPy, I could say Z for 0. I could just allocate like a NumPy.zeros, and then I could say 5 zeros. And then notice that Z is there with zeros. If I change that one to a 10, I'll get 10 numbers. Similarly with ones is equal NumPy.ones, and then say 10 numbers, and then say 1. You can see that is there. And if you say ones is equal NumPy.ones, and then 10, and then and at the same time, you could say data type is equal float. By default is float, so you can say int. and then just O is now integer. The other one was already float, so I changed the data type there. And then you can do empty, full, a lot of the other videos. I'm going to show you those ones later. Another thing you could do here is like, obviously you could say os.system and then run the command here. But if you're outside here, let me just close this one, exit, and then exit. So if you're here and you just want to go inside Python, and then here you want to just say run a command at the same time, get the output, like for example, using the OS module. So you can say import OS, and then you say os.system, and then let's say dir command, directory command. This would just run the directory command on the listing. And since it is just inside the OS module, remember, if I was doing this one inside the command prompt, let me show you the difference here. CMD, if I just say, this is good that I opened this one so I can show you the difference. Here, notice that when I did import os.system, it gave me an output of 0 because I'm inside the Jupyter. So the sub shell that it opens, it is the system function calls is limited on that one. But if you are inside the operating system, you say Python and then say import OS, and I'm going to move it up a little bit so you can see the difference. And then you say os.system and then run the dir command. This will run and give you the output of the dir. So in order for you to work on this one, and instead of the os.system, you want to use another shell, and you call it os.process open. You run the command, but you assign it into a stream, because the output of this command is set to a stream. So then if I just say print type of a stream, this is just a different output. So you can see is os.wrapper close a stream, right? So if I just say print the stream, then this is going to tell me that this is an object of wrapper closed at this address, memory address. So in order for me to actually manipulate that data, since it's a stream, then I say output is equal stream. So let me just show you one more thing here. Print dir of a stream. Notice that dir of a stream is actually show you that what methods and other things are available here. The method that I'm interested in, one of the method is read. So I can read the data into the stream, that output, and then it should be somewhere there for read, right, underscore here. So I could just also say, let me just make one more note here for item and dir of stream. You could say if read and item print item. So this one will show if there is a function called read or not. And unfortunately, it does not show it here, but it is there. I know as a fact that this object is showing. Let me just say if we can do that or no. Dir of stream. Okay, so let's just see if that is correct or not. P open stream, we can say output, and then is equal stream dot read. So since stream dot, if you put a dot here, the Colab should help you saying that what methods are available here. Unfortunately, it's not completing it for me. Maybe it is not there, but I'm going to try it. Read, and then that is there. So then I'm going to say print output. So at this time, I read it, and then I'm going to try to print output, and it did work. This is the output is directly. And if I do something else like host name, a shorter one, host name, you can see the output is going to just show the host name right there. And if I just change this one to, let's say, ipconfig, and then run the ipconfig, the output of ipconfig with all the network information is there. So you can do that process open with any command, like for example, in this lookup, www.mywebuniversity.com. So when you do that one, you can see that it is just running the DNS name server lookup, and it's going to show you the information. With that, I'm going to end this video because I don't want it to get too long. Unfortunately, people, when they look at the time, they don't subscribe, they don't like it, they don't view it. So make sure that if it interests you, subscribe so you can get these videos and then learn from it. I'm making all these videos for your purpose to help you out. God bless you all. Take care. Bye-bye.